Honda CR-V eFCEV, which is propelled by hydrogen fuel cells, is likely to be the subject of much confusion. Consequently, we will endeavor to clarify the situation in this article. Honda is beta testing its most recent hydrogen fuel cell technology. We assert that this is due to the fact that the Japanese brand will construct approximately 300 units annually, contingent upon demand. These units will be exclusively available for lease in California. We would wager that the cost of leasing will not exceed the cost of manufacturing, based on some fundamental estimations. Honda has declined to provide any official figures. It is probable that Honda will regard this as an R&D expense, as at least a portion of the units will be disassembled and assessed upon their return. In other terms, consider the Honda CR-V eFCEV as a concept vehicle that is available for lease. If you reside in California and have access to hydrogen pumps in your vicinity, and you are willing to be an early adopter, the CR-V eFCEV may be an ideal choice for you. CarBuzz was granted the opportunity to spend a few hours with the CR-V eFCEV at a first drive event. Although the time spent with the vehicle is restricted, it does enable us to form some preliminary impressions. At present, we were relatively impressed with the initial opportunity, but we anticipate a more extensive evaluation in the future, during which we will evaluate its livability. The Honda CR-V eFCEV is a novel iteration of the most recent Honda CR-V that operates on hydrogen gas. The letters in the name indicate that it is an electric fuel cell FCEV. The lowercase e may appear redundant, but FC vehicles are electric by default, as the hydrogen stack generates electricity. A small battery serves as a buffer for the power that flows from the hydrogen stack to the electric motors. However, the Honda CR-V eFCEV has a larger battery that can be recharged from a plug and has a range of 20 to 30 miles in its own right. The primary objective of the CR-V eFCEV is to function as a hybrid vehicle, which is a hybrid of a battery electric vehicle, BEV, and a hydrogen vehicle. It is capable of a total range of 270 miles when operating in hybrid mode with a full hydrogen tank. Hydrogen-powered vehicles, similar to BEVs, have been in existence for decades as research and development initiatives. Similar to BEVs, there is a scarcity of infrastructure for fueling them. In reality, the commercial infrastructure for hydrogen vehicles will need to expand in order to establish one for passenger vehicles. One of the reasons this is effective in the commercial sector is that refilling a hydrogen tank is significantly faster than charging a battery. Charging batteries that are large enough to power vehicles would require an excessive amount of time. The problem with passenger FCEVs is that BEVs can be powered by electricity, which is a resource that is readily available in every home. Additionally, an increasing number of residences are now equipped with solar roofs. Conversely, a substantial portion of the populace resides in apartments or owns two vehicles with a single-car garage, necessitating that they alternate between charging them. Consequently, this is not as practical for all. Hydrogen may serve as an alternative for them.